In the first half of section 6.3, we're going to look at adding and subtracting binomial radical expressions. So when we're talking about adding or subtracting these radical expressions together, we're going to use the distributive property. So basically, if you have the same radical expression that's being taken to the nth root, so to the same root, we can combine their exponents using the distributive property. So if a times the nth root of x plus b times the nth root of x are being added together, we can combine them by just saying a plus b times the nth root of x. We can say a similar sentence if we're subtracting them. So for subtracting those expressions, we can subtract their coefficients. What that would look like in an example, if we had 3 times the square root of 5x minus 2 times the square root of 5x, we could combine the 3 and 2 to say 3 minus 2 times the square root of 5x, which would just be 1 times the square root of 5x, and it would look like that. Other situations where you kind of hit a dead end, in this example, we have 6x squared times the square root of 7 plus 4x times the square root of 5. Since what we have in the radical are different expressions that can't be simplified anymore, 7 and 5 are prime numbers, so we can't break those down, we can't combine these. So if the radicals are totally different inside and we can't simplify it, we can't combine them. Similarly, in this example, we have 12 times the cubed root of 7xy minus 8 times the fifth root of 7xy. We also can't combine these because their indexes are different. So these won't combine regardless if we can break down anything in the radical. Finally, we're going to look at an example where we can break some stuff down to combine some things. Here we want to simplify the square root of 12 plus the square root of 75 minus the square root of 3. So even though everything under the radical here is different, I look at 12 and 75 and think those are big numbers. I could also pull some perfect squares out of them since I'm taking the square root. So I'm going to do that and see if anything can combine then. So breaking this down, looking at the square root of 12, I could pull a 4 out as a perfect square. So I'm going to rewrite that as the square root of 4 times 3. Next, with 75, 25 is a perfect square. I can pull that out. The square root of 75 can be written as the square root of 25 times 3. Finally, the square root of 3 can't be simplified, so I'm just going to bring that down into my new equation. From here, the square root of 4 and the square root of 25 are going to break out of that radical, and I'm going to be left with the expression 2 times the square root of 3 plus 5 times the square root of 3 minus the square root of 3. Now here, everything's being taken to the square root, and all of the radicals are the same. So I can combine using the distributive property. So I'm going to rewrite this as 2 plus 5 minus 1 times the square root of 3. So I took all the leading coefficients and combined them together. Simplified, 2 plus 5 minus 1 will give me 6. So my final simplified answer is 6 times the square root of 3.